Ok, on va commencer. Yes, in English, sorry. Last time I was the same. I did the whole presentation in French. Nobody understood anything, but okay. So I'm going to speak about something that is maybe simpler than what you are already listening. So it's a storage engine that is part of MariaDB, and that is quite a kind of a tool that can be very useful in many circumstances. So the idea is that, of course, you store data in a database, but many of your data might be outside of your database. It can be flat files, external database like the DB2, SQL Server, JSON file, XML file, and so on. So the idea is how to build query on these external data sources. So it can help for migration, for making maybe a cohabitation between a different systems. For example, you have something on SQL Server, something in MySQL, and you want them to interact in real time. Okay. So most of the time, people, they don't do that. They build a system with an ETL in between. It's complex, it's costly, it has to be maintained by the IT. It's a different technology. Of course, you can use open source, you can use Talent, you can use some piece of software to help you move the data. But moving data is costly, painful, and not always the best way to integrate a different system. Okay. So Connect is a storage engine. So what that means is it plugs into MariaDB. It benefits from some of the features of the storage engine API. So for example, you can mix a connect table with a normal table to do joins. It implements a condition pushdown. For example, if you have a query with a where clause, it will push the condition to the storage engine. Yes, that's the main point. What is specific to MariaDB? MariaDB has two interesting features. The capacity when you create a table with a storage engine to have a set of parameters that are specific to the storage engine. So here with Connect, we will use this capability, for example, to specify some information. For example, imagine you create a table on a JSON file. You want to define the depth you want to go. It's a parameter. So there are many parameters that you can have to the create table. Another very interesting feature that is used is the capacity to auto-discover the structure of the table. Normally, when you create a table, you give the column type, column name, and so on. Here, you can create a table based on something that is external, a file or a remote database, and the storage engine will auto-discover the structure. So it can be very helpful when you want, for example, to migrate existing data that you don't want to write a lot of SQL code. You can automatically discover. Or for example, if you have an XML file or a JSON file and you don't know really the structure, you can create a table based on this file and you will get in the dictionary a description of the structure of the file. So it can be helpful. Okay. So it has been, it's a contribution from an outside developer, so I work closely with them to define what we do and so on. His name is Olivier, it's an ex-IBM guy, and he's doing a great job. So for me it's a pleasure to present this job. So it's a storage engine, so what's a little bit complex, it supports various formats. So you might say, but all of these formats correspond to data that is outside of the storage engine. In fact, it's just a proxy to other kind of data management system. It's very different from other storage engines that will embed the management of the data. It's not the case. Okay. So first of all, it supports file format. So when we use file format, you can almost query and build tables on any kind of format. I mean, a binary file, a CSV file, a JSON file, XML file, anything you can think about. So this is powerful because, and you can build a table based on multiple files. So that gives flexibility. It supports some other concepts. For example, you can have a table that is a list of the physical directory. that can help too. It can be built on compressed file. For example, you have a file that is sitting outside and that has been compressed. You can build a table on this file. Okay. And what is interesting, even though it's an external file, you can build an index. Suppose you have a big 1 million line CSV file, and you say, okay, I would like to do some query on this file. That's something else. So here you can build a table on this CSV file, build an index on some particular column that you want to filter, and run a SQL query on your file, without doing data loading and all the painful stuff you are usually have to do. Okay. So there are many formats supported. I will just focus on a very few ones. One of them is ODBC. So you can create a table based on an ODBC. So ODBC is not very sexy, but it's a driver that is supported by almost any kind of database. So suppose you have SQL Server, DB2, Oracle, and so on, and you say, oh, I need some data that is there. And you are not really fluent with all the admin stuff on this. You can really create a table with a DSN that connects to the remote table, and that's it. You can query it. So it supports insert, select, update, and in fact any kind of command. I will show you how you can use it. In the case of, it's a little bit particular, but for example, you can access Excel files through ODBC. So in that case, you can have a multiple file. It runs on Linux and Windows. On Linux, you have to install ODBC driver manager, so Unix ODBC, and then you install the real ODBC driver from the target. For example, if you want to access Oracle, you need the client library and so on. Okay, so that's possible. So when you build a table, a connect table through an ODBC driver, first of all, you can do auto-discovery, which is nice. So you create table, you don't know the structure of the table, it will be auto-discovery. But what is very interesting is that you can build a table based on a remote query. It's very interesting because when you run a query on MySQL, it has to comply with the MySQL syntax of the query. But the target database can have a syntax that is more rich. For example, if you take Oracle or SQL Server, maybe they are much richer regarding SQL analytic function, windowing function, a lot of stuff that does not exist in MySQL. So you can create a table which is based on a query. So in fact, the query is executed remotely. It can be, for example, you do a connect by prior, which is a syntax for hierarchy that exists in many databases, but not in MySQL. But you can create the employee hierarchy based on this query, and then you can select on this table. So that's nice, because this syntax is not supported by MySQL. It's also very useful, for example, if you want to run a very heavy query that is costly, that requires, for example, parallelism that does not exist in MySQL, but that you could have, for example, on Oracle. You can run this kind of BI query on the remote target and get the result in MySQL. So that's nice. What we have done also is sometimes you want to do, so there is the standard stuff of SQL, insert, update, delete, but sometimes there are some exotic commands on the remote target that you would like to run. So what we have done is you can create a kind of virtual table, and in fact when you select from this table where command equal any kind of command, like a create table and so on, the command will be remotely executed on the ODBC target. So that opens the door to any kind of execution on the target. So that creates a lot of flexibility. So that's for ODBC. So ODBC, nothing sexy, but very useful. Another concept that exists in Connect is the ability to create a table that is made of many tables. So the idea is to say, I don't know if you know the merge table that exists in MySQL, not very useful, but because it's very limited. Here you can build a table which is in fact a set of tables, but based on tables that are any kind of table. They can be ODBC table, file table, and so on, and it is seen as a table. So this also is an interesting feature because, for example, if you have somewhere a SQL server or an Oracle table, and they belong of the same functional domain, for example, a CRM, and they have kind of same structure, you can build a table that mapped on this table and query both at the same time. So that's a feature. Yes?
How does it work under the hood? When I start querying these tables, is it different threads?
Yes, we can talk about it later, but it does a parallel execution on the target. So one of the main two formats I will talk is XML and JSON. They are kind of related because both is hierarchical structure. XML is maybe more heavy but more formalized with schema description, with a real data types and so on. But basically for us it's almost the same. It's for example here you describe a set of books with a list of authors and so on. It's XML. You can create a table, and in fact each column will be mapped in the field format to an XPath syntax. So in XML you have a very well-defined syntax to address inside the XML content. So we will use that to map each column to each XML content. So what is good, you can have a very complex stuff and you create a simple table that just extract a few fields that you are interested in. Okay? And once you have done that, you can query this table as if it was a very standard. And what is interesting here, we create the books, and for example, the author, it's an array of author, it's a set of author. And you can do a kind of group concat, and I will go back to my previous slide, by doing author, doesn't matter, here I just have one author, I will show it with JSON. So that's powerful. So JSON is kind of XML, but not much more usable, we should say. It's widely used by that as a content format for Codebase, Mongo. It's used in many API, REST API. Many systems, they log the stuff in a JSON format, so you end up with a JSON file. So what do we do? What do you do with this data if you want to query this data? Do you write a program? Do you so here, so first of all, JSON, MySQL was very late regarding JSON, so now we have Facebook has done some job, Oracle MySQL has done a great job doing the native JSON support. We were really late compared to PostgreSQL or other database. MariaDB is even later because we don't have it yet, but it's coming, so don't worry. Okay, and some features are not yet there. So there were some interesting stuff here to complement this. Zeta wrote some UDS, there were some import, export tool and so on. And as you say, you have seen it's used as a format to output some command for explain and so on. But it was not really there. So the target of the Connect Storage Engine is not to replace any of this stuff, it's just to address the case of external file in JSON. How do you query this file? That's just the target. So if we take the example, if you remember the XML that was very verbal, it's the same, but much more readable. So it's a set of books, so with identifier, an author field, which is an array of author, title, and so on. So this is a very classic JSON. So what you can do is you can create a table, and each of the columns, it's the same that for XML, will be associated with a format which is a JSON path format, a path that describes how you map the column to the JSON content. What is very specific is Connect is really target, it's not an OLTP storage engine, it's more targeted for BI, I should say, for reading data. So there are a set of functions related to aggregating, grouping, and so on, content. So for example, here, when we say author, it's an author bracket and it will simply take the list of authors, which are in fact in an array, and concatenate them as if it was a single column. So basically, if you look at the result, you will get something like this. So it's a French books on XML. and you have a set of authors separated by an end, which you have specified, but it can be a comma or anything you want. Okay, so that's a possibility. Just a detail, but most of the time you have various ways of getting a JSON content. It can be just a big JSON object, it can be an array of objects, it can be a list of objects. So Connect Storage Engine supports these various formats, and you can even say that your table starts at a particular field in an object. So here, for example, if you export some data from Facebook, you get an object, and one of the fields is the data, which is a list of objects. So you can directly map your table to a subpart of the file. Okay, so that's the syntax to do it. Nothing really special. So what we have done, which is very specific, is as I mentioned, it's targeted to more to BI-like queries. So we have added some capability to express through the syntax aggregation. So for example, you can have the sum, the average, and so on, the number of elements of your JSON content. So for example, if you have a list of facts that express expenses, so that who, when, expense, and an expense, you might want to do some aggregation on your JSON content. So what you can do, you can create a table, so with who, when, and in fact, what is a kind of group concat where you aggregate the subject, and then you can express with the syntax that you want the sum, the average, and so on. So it's a very rapid way to write query on a JSON content with aggregation. That's a possibility. Okay, so one of the main features is the same that you got with XML is auto-discovery capability. Suppose you have a JSON file, you create a table, you say nothing about the column, it will auto-discover the structure. So that's interesting. Okay. You can even build a catalog on this JSON file, and then you could query this catalog and have the detail of the data structure of your JSON file. It can be useful for if you get a JSON file, you don't know the structure, you get the catalog, and then you build the table. Okay, this is another way, but you will have the slide. You can do the other way. You have existing data relational, you want to build a JSON file, you can use it, you can do it. Okay. As with the native type, we have a set of UDF that help you build, query, modify JSON, and that helps you manipulate your JSON content. Okay, so that's an example of modification. So the documentation is quite good, so if you ever want to try it, just go to the knowledge base, MariaDB knowledge base, you have a very good documentation, so you can try it. What's next? So there are various things we might try to do, for example, supporting native JSON format as a file. Some extensions that I find interesting would be to be able to access a REST API which produces JSON and see it as a table from MariaDB. Okay, so to be clear, so the Connect Storage Engine is a kind of tool to help you address outside data. The JSON part is interesting. It's very complementary to native format. It's just there to address the problem when you get JSON content in log file, in any kind of file. Okay. What I want to say, and for me it's very important, is the developer. Most of the time when you talk about development, you say new kid, startup, and so on. So the developer is more than 80 years old, so that's nice. He didn't know GitHub, he didn't know our bug system and so on. So he learned all that from the MariaDB team with their help, because so we like to help people from outside, and he's not very efficient. And so he's doing this for fun. So some people do crossword and so on. So he does development. That's it. That's it for me. Any questions? Most of the stuff are writable. Even with file, you can modify, but it's not really targeted. When I mean it's not targeted for OLTP, I mean it's not designed for taking care of concurrency, like when we speak about InnoDB that you are really seeking reports and so on. Here it's more, you can do it, but we don't manage all the stuff about concurrency and so on. But if you want to modify a JSON file, you can do it. Yes. So that's a good question, because when you have, for example, a JSON file, you get a table that is mapped on this JSON file, and all the stuff that you would do at the JSON level, you can do now at the SQL level, filtering, aggregating, and so on. We have put some stuff to do some aggregation inside the syntax of the column, but that's not really mandatory. You can have a kind of flat representation and do pure SQL on it. So there is a choice, yes. And then when you go the other way, you can create a select and put it on a table that has just a character field, and it will turn into JSON automatically. Or you can use a UTF function to build explicitly the. So, for example, if you want just to take a few columns and build a JSON based on it, you can use a function to build a JSON and get it in a file.